Hello everyone, welcome back to the another session in Principles of Programming Languages. Today we'll be going to talk about the next topic of 4th unit about abstract data types. We were learned in the last video that what do you mean by abstraction and how abstraction is being provided. So this video is going to be looking into each language, the language which support data abstraction. Concerned to the last video, we were discussed about what is abstraction and all, and we were seen about the programming languages which provide data abstraction. So in the last video itself we were discussed about some few languages, the languages which provide object oriented features. That language will support data abstraction, right? So concerned to this, we were listed few languages in the last video. That languages are what? Ada as a language, C++ and Objective-C and Ruby, of course Java. So these are the programming languages which support data abstraction. Now we'll be going to see each language how it supports data abstraction, how essential attributes will be hidden to the user, and how access specifiers will be used by the programmer. So these things we will be going to learn from each video. Right. Now as far as this video is concerned, we'll be going to talk about abstract data types in Ada programming language. So this video will give you much information how parameter passing techniques will get implemented in Ada and how packages will get initialized. So all these kind of things we'll discuss in the video. Now, so let's look into one by one. Basically, Ada is a language which provides data abstraction. What do you mean by data abstraction? So we learned in the last video data abstraction. It is a view or representation where we'll hide essential attributes and we'll provide some access specifiers to be hidden from the special users, correct? So this is what the definitions we were given in the last previous video. Now coming to Ada, how it supports data abstraction. It supports data abstraction with the two parameters. The first parameter is encapsulation. The second parameter is information hiding. Encapsulation is what? Wrapping up of data or binding the different kind of data together. Let's say that I have three classes, A, B, C or classes. Now I wanted to use this A, B, C classes into my program. Now I wanted to implement a program where I need these three classes to be in my program. Instead of writing again these three classes which are already existed, we'll bind these three programs or else we'll wrap those three programs into one particular file. And this file I'll be going to include into my program. So this is what actually the encapsulation process is. Now, as far as Ada is concerned, encapsulation will done through packages. So a package is what? Collection of classes. So whatever classes we require to a program, that the classes will get included with the help of packages. So basically Ada will use two kind of things. These packages are specification package and the body package. Specification package is what? We will tell the user what kind of particular function with the parameters are used. And body package is going to contain how the implementation process will take place. Let's look into the example. I wanted to implement a stack program. Fine. The purpose of this code is what? Implementing the stack operations. That's what this program, and we wrote this program in Ada. So this program will be having functions. So we'll specify all the stack operations in the specification part. And implementation part of each function. Let's say stack operations or what? We'll create a stack, correct? We'll create a stack. We'll create an object to the stack class and we'll perform the operation of push and we'll perform the operation of pop will specify all these kind of function specifications in the part of specification package, and implementation of each package will prefer to write in body package. So this is what the thing what we'll be going to find in this program. Now let's see. The following is the package specification for a stack implementation. So this is what your specification package. As far as the explanation is concerned, this program is going to have, the program what you can see on the screen, it is specification. So there will be another program where we say it is a body package. Now let's look into this thing. Now this is what package stack pack is. The same way we'll be going to have body pack. Now the visible entities are public interface type stack types. This is what the package will be taking into the program. Now this is what comment lines in the ADA. We'll use double slash as the comment line in ADA. Now limited private is the access specifier. So here in the last video itself we covered this point. The point is what? Information hiding. This is a feature which is supported in ADA, or else ADA even will be having along with the encapsulation information hiding, and there are 5 access specifiers to hide the essential information. Those 5 are what? Public, private, protected, limited private, limited protected. These are what 5 different kind of access specifiers which are being supported in ADA language to hide the essential attributes. Fine. Now here we have 5 attributes. I am using one of it, which is limited private. So with the limited private, we will be allowing the concerned user to take access on this code up to this figure. We will be giving the input as 100, up to that figure we will be giving access. So that is what limited access will be given to the particular user. Now we are writing a function. Function is a keyword. At the time of we taught about the functions, there we were discussed about, there are few languages which will use function as a keyword to define a function. So ADA is one among it. ADA uses function keyword to define a function. Function name is what? Empty. Now STK is what? Object of this class. So I told here stack type is a class. I am creating a object for this class stack type. Now look at this in. In is a keyword. Now that keyword will represent the parameter will be going to take the value of this. STK is a object. This value will be going to come through in mode. Fine. We were discussed about functions, parameters, the semantic model. There are 3 kind of semantic models: in mode, out mode, in out mode. In mode is what? Will pass the value, correct? So we'll pass the value of it from actual to formal. And so we'll move procedure push, STK in out, stack type, element in integer. Now this is what actually it should become here. Now let's say that element in integer is also, it will be here. So basically we'll prefer this semicolon here in the function as a parameter. So now the parameters are what? STK is a parameter, element is a parameter. For which function? For this push procedure. So the difference in between function and procedure is what? Procedure will never return a value. Function will return a value. And the other things will be quite common from function to procedure. We'll write a block of code. We'll use the instructions what are needed to perform that operation inside the block. But the difference is what? Procedure never returns a value. Function will return a value. Now, procedure push also the same. It will also act as a subprogram. It is having 2 parameters. The first parameter is STK, and the parameter value will be going to get from in out mode. And this object is from this, for this class, stack type. And element is what? It is also one of the parameter. The value of this will get from in mode. So actual to formal. And integer, the data type what I have mentioned. The other one is what? Procedure pop. So it is also not returns any value because I have mentioned with the name of procedure. And STK is parameter. The value of this parameter will be from in out mode, and this is the class name. Now function top, to return the top of the stack. Now keen observe, wherever I wanted to return a value, so there I have used the term of function to say it is a function and it returns a value. And now these are what actually visible to the user. And what are not visible, this private access specifier wherever I have used, that part is not visible. Now what I'm hiding this particular data. This data will get hidden, and these are the essential attributes. If these attributes are modified by any of the person, then entire code will get spoiled. So that's the reason we were taking these are all essential attributes and we were keeping inside of private. Now look at the other thing, which is of body package. I said right in the previous slide that ADA will contain two kinds of packages. One is specification package, the other one is body package. So this is what body package. The entire code is body package, and this package will have two classes, with the class, use class. These are what two classes, and you can find on top of it with the use. With ada.text_io, use ada.text_io. What the purpose of these two are? With the class will be going to access the input output things from ADA, and use class whichever are needed to the program, that only will take. The other, if I have any type qualifiers or something I don't want for this program, will eliminate from the program. So that's what these two classes will be useful in ADA, with and use. Now we'll move here. Package body stack pack is what? This part is going to have implementation part. Fine. Function empty, stack in stack type, return it as boolean. So that's what it returns a value. And procedure push, it have two conditions. When we'll generally push an element into the stack? When stack is empty. When stack is empty, push operation can be done. When stack is full, pop operation can be done. So we'll take the conditions to put the element inside of the stack, and we'll take the condition to pop the element from the stack. So that's about the programming of abstract data types in ADA. Thank you all.